Alright, here's a video of the graphing and let me say that again, graphing inverse Desmos activity. We did this in class together. If you missed class, then you can watch this video, or if you failed to understand some of the points of the lesson, then you can come here and look at this video. So here's the first slide. It's an introduction slide. Then on slide 2, you're supposed to input these x values into this function here and get the output. So if I put a 0 on here, that makes this whole thing 0 minus 6 would be negative 6. And then when I put a 1 in here, I get 1 squared, which is 1 times 2 is 2 minus 6 would be negative 4. Then when you input a 2, 2 squared is 4, times 2 is 8, minus 6 is a 2. And then when you input a 3, 3 squared is 9, times 2 is 18, minus 6 is 12. So that takes care of slide number 2. Slide number 3 is the inverse of the inverse function of the previous slide, and you'll find that out as we go along. But if I plug in a negative 6 plus 6 is 0, divided by 2 is still 0. Square root is 0. Then when you plug in a negative 4 here, negative 4 plus 6 is 2. 2 divided by 2 is 1. Square root is 1. Then when you plug a 2 in, 2 plus 6 is 8. Divided by 2 is 4. Square root is 2. And then finally, plug in a 12. 12 plus 6 is 18. Divided by 2 is 9. The square root of 9 is 3. So the output is 0, 1, 2, and 3. And that's slide 3. And then slide 4, here's my answers. You're supposed to compare them to these down here. And they match up. So compare your answers. If they're different, go to the previous slide, see if you can find your mistakes and fix them before moving on. So my tables are correct. And then on slide 5, what do you notice about the values in the table? Record your observation below. The inputs and outputs are swapped. So here the input is 0, the output is negative 6. Then over here, the input's negative 6, the output is 0. Slide number 6. Plot the points and then sketch the graph. So the original 0, negative 6. So I'd come down here and plot a point. And 1, negative 4. And 2, 2. And 3, 12 is off the graph. So it says if it doesn't, the point doesn't fit on the graph, just skip it. So now I want to try to sketch this right here. It's actually half of a parabola, so it's a curved shape here. Kind of missed that dot, but let me do it again here. Try to make this a little bit better. Let me see if I can write on the pad here. Let's see if I can get, whoops. See if I can get it here. There we go. That's a little bit better. And then -6, so I'm going to do it in a different color here. -6, 0, -4, 1, 2, 2 is this same dot here. And then 12, 3 is off the coordinate plane. And then taking my stylus here. So if you have a stylus at home, or you have some kind of other iPad or something, it's probably easier to draw on it. And so one thing that I could put on here is so this is, whoops, this is the line y equal x here, this dashed line here. And so that's what one of the outcomes of this lesson is supposed to see, that the orange graph is reflection, the blue graph is the reflection of the orange graph over the line y equal x. So the line y equal x is a reflection for a graph, a line of reflection for a graph and its inverse. All right, then they drew the line y equal x in there, so I didn't know that was coming up next. But so what do you notice about the relationship of f of x and g of x in regards to the dashed line y equal x? So f of x is the other way around. G of x is the reflection of f of x across the line y equal x. All right, number 8, it says practice reflecting the points here. So here's -3, 1. And if I reflect that point, it would be 1, -3, and 2, -2, and 4, -1. And then I want to make those in orange there. So 1, -3, and 2, -2, and 4, -1. So if I connected these together, there would actually be y equal x would be the perpendicular bisector of these line segments connecting these inverse points here. And then number 9, use symmetry to sketch the inverse here. So the easiest way for me to do this is try to figure out some points on this graph. So this looks to be about 0, -3. So I would go to -3, 0 and plot a point. And this point here, it looks to be about 0, 6. So at 6, 0, plot a point for the inverse. And then over here, looks to be about, if I went up here to, let's go cut across here from 10 and see where I end up on the x here. So it looks to be about 10, whoops, I'm gonna do that. So about negative 7, 10. So 10, -7 is right about here. All right, then I'm going to take my line segments tool, since this is an absolute value shape here, a V shape. Let me connect together the dots a little bit better. So it goes like this, and then down here. All right, and there's the orange graph is reflected, the reflection of the blue graph across the line y equal x. So the orange graph is the inverse of the blue graph. And then once again, we'll try to pick off some points here. It's a little bit harder because I have to estimate. So in orange, so at right here, 0, 4, the inverse point would be 4, 0. And then this is on the line itself. So the inverse is also going to intersect the line y equal x. Then about right here, is about -1, 4. So 4, -1. And then way up here is about 5, 15. So 15, 5 over on this side. And then the symmetrical point, -5, -15 would be -15, -5. So right about here. Okay, and then if I try to sketch that, let me use the stylus again here. So we click on the pencil and come down here. Ooh, this is going all over the place here. Here, a little bit more stable now. So try to stabilize this stylus here. All this here. Whoop. All right, so a little bit of a glitch right there, but if you drew that on your paper or on your Desmos activity, that's close enough there. All right, so here's a table. For h of x, make rx the inverse of h of x. So just switching the x and y's. So -2, 0, 1, 1 stays the same. If I swap the input and output, still both 1, 0, 2, swap the input and output, and 6, 3. Swapping the input and output. Okay, just make sure you're swapping the input and output. You don't negate anything. Don't make anything in the opposite value. That's a common error, is people just do the opposite values. Okay, and then finally, the last screen here. So answer the following with what you learned in this activity. How can you determine if two functions are inverse but by examining their respective tables? So in the tables, the inputs and outputs are swapped. And what about examining the graphs? The graphs of inverses or reflections they're reflections of each other in the line y equal x. Okay, so that's a video of the Desmos activity.